Hi, welcome to this lesson on statistics regression. Let's have a look at measures of dispersion. So just as we've seen before with measures of central tendency, those specific values, the mean, the median, and the mode, tell us some sort of information about our data set. The average of the data set, the value that's in the middle if you put it in ascending order, and the value that occurs most often. However, there are other statistical measures which have a lot of useful purposes. One such is the measures of dispersion. Measures of dispersion tell us how spread out the data is with respect to something. And usually that's with respect to quartile values or actual data values in the sets or the mean. All right, so it talks about how spread the data is usually around those measures of central tendency. All right, so the range, that is defined as the maximum value of your data set minus the minimum value in your data set. Okay, so let's have a look at a specific example, and we're going to apply the principles in this to solve this problem. Okay, so let's say, for example, our data set was 5, 13, 14, 26, 29, 30. All right, so we have n equals 6 data points over here. All right, and within that, we can calculate a multitude of things. We can do the mean. So if you want to do the mean quickly, how can I do that? Well, we're going to bring up our calculator, and I'm going to show you exactly what we're actually going to be using on our calculator to work out these values. Okay, so this is going to work like this. So we're going to push a mode, and we're going to choose stat, wherever that is. And because we're dealing with just ungrouped data, and we put it in ascending order, I'm going to choose one variable. And you're just going to put your data points as you see them. So 5, 13, 14, 26, 29, and 30. Okay, then you can clear AC. So that saves all that data in that table. And now if you wanted certain values, like the range, for example, we will go shift and wherever stat is on your calculator. So that's 1 on this calculator. And now it's going to ask you a whole bunch of things here. You can see min max at the top there. If you press 6 and you want, let's say, the minimum of your data set, I would press 1. And you can see it says 5, which is the case here in our data set. I can click AC and go shift stat min max again and choose 2 for max. And you can see it shows me 30 as my maximum value. All right, so in this case, it'll be 30 minus 5, which is 25. So that would be your range. That tells you how far apart your data generally is from the highest to the lowest. The interquartile range is another measure of spread, right? So how spread out your data is in that middle 50%, because it's going to look at the quartile 3 value, which is what we call your upper quartile, minus your lower quartile value, which is your Q1. Okay, and if I go to my calculator again, go shift stat min max, you can see there's Q1, median, which is Q2, and number 5, which is Q3. So if I wanted the quartile 1 value, I'd press 3 here, and you can see the quartile 1 value is telling me that it's 13. So I can go 13 is my quartile 1 value, okay? And then I can look at the quartile 3 value. Okay, so if I go shift stat min max and push 5 for quartile 3, you can see it showing me 29. So Q3 is 29. All right, so from that data set, the interquartile range is going to be 29 minus 13, and that's going to give you 16. So what this is telling us, if you think about your 5-number summary and your box and whisker diagram, okay, is it saying that within this middle 50% of your data, between Q1 and Q3, the spread between that is around 16 in terms of whatever this 16 would be in context of the question, 16 units of whatever the question is asking. Okay, so that's the interquartile range. The variance is the measure of the average distance squared between the data points and the mean. What this just means, average distance squared, is that you look at each data point xi, and you look at the difference between the mean and you square it. Then you're looking at the average of that. So you sum it up and then divide by n. So you usually see a formula like this on a formula sheet. All it means is your variance is just looking at how far is your data points from the mean, but in a square position. All right, and our calculator can also help us with that. So if I go shift stat And now it's not going to be under min-max, but you see 4 for variable asks us now the X bar is your mean. So if I wanted mean, I can press 2, and you see the mean of the data is 19.5. I can also go shift stat variable 3 for the standard deviation, okay, which is 9.36 to 2 decimal places. And the value that we use, or the symbol we use, is sigma. So this is a Greek letter. This is the small letter for sigma. Okay, so it's a lowercase sigma. And when we square that value, we get the variance. So if I square that value, 87.53, that is this value here. That is known as the variance. Okay, so standard deviation is essentially the square root of your variance, and it measures how spread out the data points are with respect to the mean. Okay, so the mean I think we saw was 19.5. All right, so let's just go and double check that. Shift stat variable mean, 19.5. So basically, if you are 1 standard deviation above the data, that would mean X bar plus 1 sigma. If you were 1 standard deviation below, that would mean X bar minus sigma. So you would say 19.5, for example, here, plus 9.36. Or over here, 19.5 minus 9.36. And whatever values you get out of that, that is telling you that's how much data lies within 1 sigma of your mean. That's what we mean by when we say 1 sigma or 1 standard deviation within your mean. It's either 1 standard deviation above or 1 standard deviation below. Right, so that's what the standard deviation is telling us. Okay, so these have been the measures of dispersion. I'll see you in the next one.